Our next speaker, we skipped over you, Jim. Thank you for, Jim is one of the hardcore, really focuses on the science foundations. At Sandia, we differentiate between the science foundations and then the programmatic applications of that. But he's in material research, he's in charge of material sustainability, and is a real champion for how material sustainability fits into the peace engineering vision. So Jim, would you join us now and talk about that?
Thank you very much. Good morning. So I really appreciate the invitation to be here and speak to you about materials for sustainability and the work we're moving forward at Sandia. You know, I really enjoyed the last talk by a medical doctor from Sudan about the regional global challenges that exist. Very interesting to hear that. Glad to hear some optimism at the end of the last talk. And our very first topical speaker, Joe Hughes from Drexel, used the term, it's a wicked problem. Peace engineering is a wicked problem. Now, if I could share my own regional experience, I grew up in New England, Connecticut in particular, and the term wicked has a positive meaning in Connecticut and Rhode Island in particular, and I think it's wicked cool to be here. So thank you very much for the invitation. And really what I hope to get out of this and as we hear throughout the day is the opportunity for partnership and collaboration. That's something that we care tremendously about at Sandia. And as I talk about the Material Science Research Foundation and what we're trying to do as a strategy around materials sustainability, that's essential to our success. Okay. Next slide. All right. So Material Science Research Foundation, this is one of a handful of foundations at Sandia that is an entity that's put into place to help meet our mission needs at Sandia. So Sandia is a national security laboratory. Materials research has played a pivotal role in all of our mission space. My background is in organic and polymeric materials. And so I'll talk a little bit about that in a moment. But we have a great team that's working this strategy around materials for sustainability as it applies to things that Sandia needs to do as a national security laboratory. So there's a picture of our team. The top images are all prestigious scientists in their own right from multidisciplinary areas. The bottom images are managers that are helping move the strategy along. So the Material Science Research Foundation, it's one of the bodies at Sandia that has what we call laboratory-directed research and development funding. And that is funding that is appropriated to Sandia and some of the other national labs to conduct fundamental research. And what excites me about Sandia and what excited me 23 years ago when I started was the opportunity and ability to conduct innovative and creative research and creating new materials. And so the comment that there are no new ideas, I don't know if Mark Twain would say that today in the explosion of science and technology that we have. But that's what excites me and what excites me about materials for sustainability for us that we're trying to develop for the Material Science Research Foundation. So we have a definition for on the last slide, we have a definition of sustainability. If you look at sustainability, there's a number of definitions out there. This is the definition that I think we settled on. Sustainability is a concept that encompasses a circular economy of reuse in concert with reliance on renewable or abundant resources leading to zero human footprint. So that's what's one of many definitions out there. And I think we tweaked some of the other definitions and ended up here. And really our goal is to leverage the people, the expertise, the science, and the ideas at Sandia to work toward a peaceful engineering for materials for the world. And we have some exemplars that we sell. One is around responsive materials degradation. So you're probably all familiar with the images of the massive floating plastic wastes in the ocean. microplastics on Mount Everest and et cetera in the national news. So we have work around responsive materials degradation that I'll talk about. We're a national security laboratory, and so national security materials are very important to Sandia, and so I'll mention some materials research there. And then materials for enabling energy efficiency and climate change. So Rob Leland's new center has been stood up recently at Sandia, and we are looking forward to partnering with Rob and the folks in his center. And so we'll talk about some exemplars there. And really, how are we going to do this? We're going to do this by accelerated innovation, creativity, through chemistry, processing, and predictive computation. And as I mentioned, what I'm really excited to hear is folks that are online, folks in the room. If you see something here that interests you and excites you, please get in contact with us. Okay.
He's saying he has money.
So the LBRD process, some of what I'm going to show you is newly funded, deliberate intent for the Material Science Research Foundation to invest money in material sustainability. Okay, that's absolutely true. So the motivation is, we recognize, the rest of the world recognizes that there is national impact and worldly impact to our environment that is unsustainable. And the expertise at Sandia can be brought to bear to address those issues. Now, many times, Sandia, and Rob alluded to this in his presentation, Sandia, one of its unique attributes is that we bring together very quickly a multi-dimensional team of expertise and folks. So multidisciplinary team of folks to address a problem very quickly. So some examples of that, Rob probably has more specifics, but the Gulf oil leak back in 2010, I believe, a former lab president, Sandia lab president, led the charge in helping Sandia help the aspects of that problem, of that massive oil leak under the Gulf of Mexico. The Challenger accident, when upon liftoff, foam from the Challenger impacted one of the heat tiles on the shuttle, and that ultimately was the result of its destruction in the atmosphere. And so Sandia brought to bear its foam experts and other material scientists to partner in understanding how that problem occurred. So Sandia has played a major role in natural disasters, in accident investigations, and then certainly in innovation and creativity to solve major problems. So we have 3 exemplars. One is around developing economically viable chemistries and processes for engineered degradation of commodity materials. And so the whole aspect of recycling of plastics is very problematic. It's very costly. Even recyclers are going out of business. Just down in southern New Mexico, I think it's Roswell. There's a recycling company that is just not cost effective for them to collect the recycled plastic items and process them. So there's a major issue globally around recycling, and then some materials just aren't recyclable. And I'll talk a little bit about that. We also care about national security materials, and so, for example, rare earth metals, battery materials, and being able to source them, to recycle them, to recapture them, and reconstitute them for a sustainable material stream. Then lastly, material development for reduced carbon footprint. There was a question about CO2 earlier. I'll show you another example around aspects of pollution. And so we care about those types of material developments as well. So we have, and please, if you have access to these documents, please look at the references. We have published work in how we can engineer polymers to degrade. There are basically 2 types of polymers. There's ones that melt and flow and are reprocessable nominally, and there's others that are cross-linked. And those cross-linked polymers it normally cannot be reprocessed. So the seat cushions you're all sitting on, those are all cross-linked polyurethane foams. And cross-linked polymers are difficult to recycle. So we have approaches toward how one can engineer the degradation of thermoset materials. And so we do that by a number of different methods. There's some showed here where we use catalysis and chemistry to affect the disassembly of polyurethanes and of various rubbers through this embedded catalyst that can be triggered by a particular stimulus or by a particular environmental factor that we want to occur. So we have great work there. If that interests you, the PI is Brad Jones. Contact Brad or myself. The next slide has to do with national security materials and rare earth metals. So rare earth metals, one of the largest producers of rare earth metals is China. That represents a national security issue for us. Rare earth metals are used in your cell phones and in electric vehicles. And so their sourcing and their reclamation are really important. And so we have new LBRD work led by Eric Sporky around how one can go about recapturing rare earth metals through examples of extremophiles. Extremophiles, it turns out some extremophiles biological activity have rare earth metals in their biology. And if they're good at capturing rare earth metals, then perhaps we can mimic that behavior and apply that in ways where we can all do the same thing on demand. So the last goal is around climate change materials. And so you may have heard about zeolites, or one category of synthetic zeolites is metal organic frameworks. And metal organic frameworks can be engineered to be specific for the capturing of acidic or acidic promoters like NO2, NOx, and sulfur dioxide. And so these caged molecules can absorb preferentially some of these molecules and essentially be scrubbers for those types of acidic gases that occur in flue exhaust throughout the world. So shows a multidisciplinary approach toward how we do this: computation, material synthesis, characterization. I would say all of that applies to everything I've talked about so far. That's part of the diverse nature of Sandia and how we can apply this, all these specialties to tackle a problem. And so I'm there. The last slide is just some contact information for me. It's been wicked great to be here. And if any of this interests you, please contact me.
Thank you so much, Jim. So this is just, we're all, most of it, I didn't even say that. There's a lot of engineers in this room. This is called peace engineering. And so it's really great that we finally got to talk. It's really about true engineering solutions, right? And so that's what we want to get to, is bring together these recognition of problems with, we've had the social scientists, we've had discussion of equity and inclusion, and then we've talked on engineering and, in the context of that, the solutions. And so thank you.